Assalamualaikum dan salam sejahtera. My name is Intan Liana binti Ramli. I will teach about material science and engineering, chapter 1. First, introduction to material science. Okay, 1.1 fundamental of material science. Okay, you have to know the definitions of material science. Material science involves investigating the relationship that exists between the structures and the properties of materials. Okay, this is the definition. So you have to know, you have to remember the definition. Okay, there are 4 components of disciplines of material science and engineering, and their interrelationship as shown in figure 1.0. First, processing, okay, and then structure, and then properties, then performance. So in material science, these four components is related to each other. So we will learn after this about the process, structure, and properties and performance of materials. Okay, why we study material science? First, to be able to select a material for a given application, taking into considerations of cost and performance. So, for example, if we want to have a material for a given application, so you have to know what is the cost. You have to know what is the performance the material can give. And then second, to understand the limits of material and the change of their properties with use. Okay, so every material have their own limits. For example, melting points, hardness limit, strength. So you have to understand those limits. And then third, to be able to create a new material that will have some advantageous properties. Okay, and this is really important for us. Okay, next, okay, classifications of materials. Okay, the main components of materials, we have metals. So I think everybody already know about the metal. We have polymers, ceramics, composites, and advanced material. We can divide advanced material into 4 components: biomaterials, semiconductors, nanoengineered materials, and smart materials. Next, okay, metals. Okay, atoms in metals and their alloy are arranged in a very orderly manner. That's why when you see metal around you, they are very stiff, strong, yet ductile because of their atoms or alloys are arranged in orderly manner. Maksudnya dia tersusun secara seragam. Okay, that's why kalau kamu rasa metal sekeliling kamu sangat strong. Okay, metals are extremely good conductors of electricity and heat. So dia boleh conduct electric and haba. Okay, macam sudu kalau kamu letak kat bahagian panas kat hujung sana, kamu akan rasa kat hujung sini. Kamu letak bahagian panas dekat bahagian lengkuk dia. Okay, kamu contohnya bakar lilin kat bahagian lengkuk, and then kamu akan rasa pada hujung sudu. Sebab dia adalah, because metal are extremely good conductors, okay, and are not transparent to visible light. So kalau kamu letak lampu suluh belakang sudu tu, kamu tak akan nampak cahaya menembusi dia sebab dia bukan transparent. And a polished metal surface are lustrous appearance. Okay, next. Okay, this is the example of materials in our earth. Okay, we have brass here, we have aluminium, cast iron, bronze, steel, and then copper. Okay, next classification is polymers. Polymer include the familiar plastic and rubber materials. Okay, so kita dah biasa dekat kita punya surrounding, kita tahu kita ada plastik dengan rubber material. Ini adalah dalam kategori polymer. Many of them are organic compounds that are chemically based on carbon, hydrogen and other non-metallic elements. Okay, this is the definition of polymer. When the question asks about the polymers, you have to explain about the organic compounds that chemically based on carbon, hydrogen and other non-metallic elements. Okay, they are very large molecular structure. Okay, often chain-like in nature and have backbone and and that have backbone of carbon atoms. Okay, these materials typically low densities. Okay, ini adalah poin-poin penting yang perlu kamu tahu berkenaan dengan komponen ataupun berkenaan dengan classification of material ataupun berkenaan dengan polymer ni sendiri. Okay, whereas their mechanical characteristics are generally dissimilar to the metallic and ceramic materials, and they do not as stiff nor as strong as other materials. So polymer ni dia low density dan dia punya structure tak sama langsung dengan metallic dengan ceramic. Kita bayangkan plastik lah. Plastik macam mana dia punya karakteristik dia, macam mechanical karakteristik. Okay, next we already have this. Okay, polymer, this is the example of polymers: PVC, PC, which is polycarbonate, and polystyrene. Okay, Malaysia already banned this type of polystyrene to be used in food industries. Okay, next, ceramics. When we talk about ceramic, okay, in your mind you have to think what the example of ceramic. So example of ceramic is pasu rumah, pasu bunga dekat rumah, bukan pasu plastik tu. And then what is definitions of ceramic? Okay, ceramics are compounds between metallic and non-metallic elements. Okay, inside the ceramic we have metallic plus dengan non-metallic. Okay, and then there are most frequently oxides, nitrites and carbides. Ini adalah nama-nama untuk ceramik. Nitrogen oxide, nitrogen nitrites ataupun carbides. Okay, tengok belakang-belakang dia ada nama yang 3 ni, itu adalah ceramics. Okay, so what is ceramic material characteristic? First, relatively stiff and strong. Stiffness and strength are comparable to those of metal. So dia punya stiffness dengan strong dia lebih kurang sama sahaja dengan kamu punya metals. Typically very hard, extremely brittle. Okay, brittle maksud lain dia adalah lack of ductility and highly susceptible to fracture. Brittle tu maksud dia mudah pecah. Okay, sama macam cermin, sama dengan tal, itu adalah kategori brittle. Bila kita kenakan satu force dekat dia, dia akan broke. Okay, tanpa amaran. Okay, insulative to the passage of heat. Okay, so dia insulative untuk heat and electricity and are most resistant to high temperature. Okay, and harsh environments than metals and polymers. So kita boleh dedahkan ceramik ni pada harsh environment sebab dia adalah more resistant to high temperature berbanding dengan metals and polymers. Okay, this is the examples. Aluminium, macam saya cakap tadi, aluminium oxide. Okay, ni biasanya cutting disc. Okay, aluminium oxide untuk kita ada silicon carbide. So kalau kamu pergi bengkel, kamu boleh nampak ni grinding wheels. So dalam kita ada silicon nitride, ceramic bearing, kita ada silicon dioxide, which is kita biasa pakai silika. Okay, silika dalam makanan. Okay, next classification adalah composite. Okay, definition of composite. A composite is composed of two or more individual materials, which is metal, polymer, or ceramic. So we have composite. Sometimes combinations of metal and polymers, sometimes combination of polymer and ceramic, sometimes three of them have combinations. Okay, the design goal of a composite is to achieve combinations of properties that is not displayed by any single material, and also to incorporate the best characteristic of each of the components material. For example, okay, kita ada metal. Okay, kita nak sifat metal tu strong. Okay, tapi metal ni strong, dia kurang daktil berbanding polimer. So kita tambah polimer. So sifat polimer ni, okay, bila kita dah gabung kedua-dua ni, kita akan dapat material tu keras, strong, strong like metal, strong and stiff, and then kita tambah polimer untuk dapatkan dia punya daktil tadi. Okay, very daktil. And then kita plus ceramic, mungkin nak tambah lagi property ceramic yang ada. Okay, next example of composite is fiberglass, in which small glass fiber are embedded within the polymetric materials. Okay, normally epoxy and polyester. Okay, so kita tengok sifat glass ni relatively strong and stiff but brittle. So, kita tahu glass dia mudah pecah. Sekali kita kenakan force, dia akan terus pecah. Manakala kalau polimer dia adalah daktil, tapi dia weak and flexible. That's why kita gabungkan dua ni, okay, glass dengan polimer tadi untuk dapatkan fiberglass tadi, supaya kita punya material yang kita ataupun komponen yang kita campurkan jadi stiff, strong, flexible and ductile. Dan yang paling penting, low density. That's why fiberglass banyak digunakan untuk boat. Okay, speedboat. So sebab kita tengok speedboat tu dia tahan, dia strong and stiff, tapi dalam masa yang sama dia boleh terapung atas air sebab sifat yang ada pada polimer tadi. Okay, next. Okay, last kita ada advanced materials. Okay, advanced materials that are utilized in high technology or high-tech application. And then these advanced materials are typically traditional material whose properties have been enhanced and also newly developed and high performance materials. So dia adalah traditional material, tapi yang mana dia punya properties tu kita dah tambah baik, kita dah improve dengan untuk kita jadikan dia punya high performance material. Okay, so kita ada 4 tadi kan, biomaterials, semiconductor, nano engineered material dan smart materials. Kita tengok apa contoh-contohnya. Okay, biomaterials, bila cakap pasal bio, okay, biomaterial are employed in components implanted into the human body for replacements of disease or damaged body parts. So you have to know the definition. You have to remember these definitions. Okay. So kalau kamu bawa motor laju-laju and then accident, kena masuk besi. So besi yang kita masukkan bukan sebarang besi. So besi itu mesti adalah sifat ni, biomaterials, supaya tahan lama dalam kamu punya kaki dan dia tidak bertindak balas dengan badan kamu ataupun cecair dalam badan kamu. Okay. Kalau kita tak pakai yang biomaterials, mungkin kamu pakai stainless steel biasa je masukkan dalam kaki kamu. So tak sampai berapa minggu pun dah berkarat. So bila dah berkarat, dia akan bagi infection pada kamu punya body. Okay, that's why biomaterial ni sangat penting. Okay, this material mask do not produce toxic substance. Okay, so dia tak keluarkan toxic and must be compatible and with body tissues. Ini adalah komponen utama untuk kita kenal pasti adakah material itu boleh dikategorikan sebagai biomaterials or not. Okay. Contoh components in biomaterials, we have socket for human body. Okay. Okay, electrical socket. Okay, so you have hip joint, pylon, rotator ini untuk lutut, knee joint, pylon juga. Pylon tu yang macam besi, macam panjang, and kita ada foot. So ada juga implant untuk gigi, biasa kita dengar implant gigi. And then ini adalah untuk tangan palsu. Next, semiconductors. Semiconductors have electrical property that are intermediate between electrical conductor and insulator. Macam tadi kita ada ceramic. Ceramic adalah between apa? Metals and polymer. Kalau yang ni, semiconductor adalah tengah-tengah antara electrical conductor dengan insulator. Okay. Maksudnya electrical conductor ni dia tak dapat conduct apa, insulator, electrical conductor dia boleh mengalirkan mengalirkan elektrik, dan insulator tidak boleh mengalirkan elektrik. Okay, insulator. Okay, so dia berada di tengah-tengah antara tu. Okay, ini adalah contoh semiconductor device yang biasa kita tengok adalah resistor, capacitor, biasa kita dengar diodes dan transistor. Ini adalah contoh-contoh semiconductor. Okay, kita ada nano-engineered materials. Nanomaterials may be any one of four basics: metal, ceramic, polymer, and composite. So antara ni nanomaterial ni mungkin ada metal, mungkin ada ceramic. So depends pada material itu sendiri. Okay, however, unlike this other material, they are not distinguished on basis of their chemistry, but rather than their size. So kita ada metals, kalau dalam saiz nano kita panggil nano-engineered materials. Okay, so bila ingat nanometer adalah 10 negatif 9. Okay, smart material are material that are able to sense changes in their environment and then respond to these changes in predetermined manner. So, bila ada perubahan pada environment, dia akan bertukar sifat. Contoh dia adalah shape memory alloys. Kita ada piezoelectric. And then, kita tengok contoh dia. Okay. Shape memory alloy are metals that are after having been deformed. Okay, bila kita deform, dia akan revert back to their original shape when the temperature is changed. So, maksudnya kita bengkokkan dia, deform, kenakan force ke atas dia, then dia akan bengkok, dan bila kita kenakan heat, dia akan kembali ke bentuk asal. Okay, ini contoh dia. Okay, lama pula intro dia.
形状記憶物質。形状記憶物質とは、ある特定の温度で決められた形状に復元する性質を持った物質のことである。例えば、形状記憶合金でできたこの針金は、まっすぐに伸びた状態が記憶されている。そのため、こうして形を崩しても、約60度以上の温度を与えれば、元の形に復元する。また、このフィルムは形状記憶ポリマーと呼ばれる物質でできている。普段は硬い素材だが、お湯につけると柔らかくなり、手で引き伸ばすことができる。しかし、この変形してしまったポリマーに再び同じ温度を与えると、元の形に復元する。次に、形状記憶合金を使い、こういったバネを作ってみた。この縮み切った状態を記憶させてある。ここでこのバネを大きく引き伸ばし、台に引っ掛け、下に小さなろうそくを吊り下げる。そしてこのろうそくに火をつけると果たしてどうなるか。炎で熱せられたバネがじゅんぐりに縮んでいき、ろうそくを持ち上げていく。
Okay, next. Okay, tadi shape memory alloy, kita ada piezoelectric ceramic material. So, this of material expand and contract in response to an applied electric field. So, tadi bila dikenakan pada haba, dia akan berubah bentuk, berubah kembali kepada bentuk asal. Tapi kalau piezoelectric, bila kita apply electric field ataupun voltage, so dia akan generate electric field and then dia punya dimension are altered. Okay, ni quartz crystal. Okay, so dia dibuat daripada piezoelectric material. So dia memiliki keupayaan untuk convert voltage, okay, supply by wash battery to mechanical stress. The frequency to move the second hand. So dia menggerakkan ni. That's why dia mahal. Was. Okay.
How do quartz clocks work? When it says quartz on your dial, your timepiece uses a quartz crystal to keep time. Quartz is the second most abundant mineral and is made up out of silicon dioxide. When compressed or bent, quartz generates a charge of electricity. Likewise, when electricity is applied to a piece of quartz, it will bend or change shape. This is called the piezoelectric effect. Jacques and Pierre Curie discovered that quartz possessed this property in 1880. Although it took until 1969 for the first commercial quartz wristwatch to become available, the Seiko Estron. Quartz can be used in very small sizes. A tiny bar of quartz is cut like a tuning fork, and then positioned and zapped to oscillate at a frequency of 32,768 Hz. That number is the result of 2 to the power of 15. The power of 2 is chosen to easily chain divisions by 2, and so obtain a 1 Hz signal to drive the watch's seconds hand. Quartz timepieces are hereby inherently accurate and conveniently cheap to produce. Want to learn more? Subscribe and/or check the sources in the description.
Okay, next. Okay, next smart materials adalah magnet alternative material is a material that change shape when placed in magnetic field. Okay, tadi electric field, ini adalah magnetic field. Okay, biasanya kita gunakan untuk switch dan sensors. Next. So, smart material lain adalah electro-optical. Okay, next adalah electro-rheological and magnet-rheological fluids are liquids that are experience dramatic change in viscosity upon the applications of electric and magnetic field respectively. So, dia akan berubah. Dan dia punya viscosity bila kita apply electric dan magnetic field. Kita ada contoh. Ada contoh ya. So, bila kita kenakan electric fields, dia akan berubah bentuk. Okay. Kita letakkan magnet dekat atasnya. Itu menjadikan bentuk dia berubah. Okay, next. Okay, ini adalah summary ataupun mind maps untuk this chapter. Okay, thank you. Thank you for attention. See you in next chapter.